Hey, this is Workbench or Workbench Quagmire back with our free Code Camp Python certification in 100-ish days. We're back here with our Implement the Shortest Path Algorithm workshop. We're about halfway through, so let's just jump right back in. We're down here, step 14. After the loop that finds the nearest unvisited node, you need to check whether a valid node was actually found. If no such node exists, that means the remaining nodes are unreachable from start node, and algorithm should stop early. On the same level as the nested for loop, add an if statement that checks if current equals -1 and breaks out of the loop if true. Step 15. If a valid node was found in the past, you need to mark it as visited so it won't be considered again in the future iteration. After the if statement you added in the previous step, set visited current to true. Step 16. Now you selected and marked a node as visited, it's time to look at all of its neighbors to see if you can find a shorter path to them. Shorter paths to them. After the line visited current equals true, add a for loop that iterates through node number in range n. Inside the loop, create a variable distance and set it to matrix current node to node. Step 17. Before trying to update the distance to a neighbor, you need to verify that the neighbor is both reachable and unvisited. Then you'll calculate what the total distance would be to reach that neighbor through the current node. Inside the for loop, add an if statement that checks that distance is not equal to infinity. And the neighbor has not been visited. It has not been visited. Inside the if block, create a variable named new distance. And assign it the sum of distance current. The shortest distance to the current node and distance, the distance from the current node to the neighbor. Should assign new distance, the sum of distance current and distance. Distances. Step 18. Now that you've calculated the new possible distance to the neighbor, check if it's better than the current one stored in distances list. If it is, update the distance. Inside the existing if block, add an if. Add an if block. Add an if statement and check if the new distance is less than distance's node number. Inside the new conditional block, update distances node number to store new distance. Step 19. When you find a shorter path to a node, you also need to update the actual path taken to reach it. Inside the same conditional block, update the path list at the neighbor's index to reflect the new shorter path. You should update path node number to the current path to be the current path to the current node with the node number neighbor added at the end. Ugh. No idea. Step 20. Once the algorithm is finished running, you need to decide which nodes to display results for. If a specific target node was provided, you'll only show the distance and path to that node. Otherwise, you'll show results for all nodes. After the outer for mid-range loop, create a variable named targets. Create a variable named targets. Use a conditional expression to assign it target if target node equals if target none means range, not a capital, range, and Right, step 21. Now that you've defined which nodes you want to display results for, you need to loop through them. Add a for loop that iterates. That iterates through each node number in the targets list and add pass as a placeholder for loop body. So. Step 22. At this point, you only want to display results for nodes that are not the start node and are reachable from it. Add a conditional that checks if node number equals start node, or if here we go, number equals start node, or distances node number equals infinity. To skip the next iteration of the loop. Oh no. Step 23. Now that you've determined a node should be displayed, you need to format its path so it can be printed clearly. For this, you will use a generator expression. A generator expression is similar to a list comprehension, but instead of creating a list, it generates each value one at a time. It uses parentheses instead of square brackets. For example, numbers equals 1, 2, 3, and squared equals x squared for x and numbers. Inside the loop, after the if statement, create a variable called string path. Assign it a generator expression that converts each node number in paths node to a string using the string method. Paths. Should iterate over each node number in and paths node number. Raised an error. Step 24, now you'll use the join method to combine the string representations of node numbers into single readable path. The join method takes an iterable, like your generator expression, and combines all the elements into one string, placing separators between each element. For example, blah, 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 with arrows. Create a variable called path and assign it the result of joining the string path using something I'm going to copy on 2 lines. Looks like an arrow. Step 25. Finally, print the results for the current node. Your output should show 2 things: the distance from the start node to node number and the path taken to get there. Use an F string to format the output to show both the distance and full path using the format. Holy smokes. Starting node is start node. And node number is distance is the distance from the start node to node number. This is going to be paths. That's handy. What did I get wrong here? Distances, node number. Step 26. At the end of the function, return the data you've computed so it can be used outside the function. Return both the list of shortest distances and the start node to all the nodes and the list of the paths that lead to each node. What? I can't believe that's even right. Now you will demonstrate that your function works. At the end of the program, call your function shortest path with the adjacent matrix start node of 0, a target node of 5. So 0 to 5 is a distance 6, and you go 0 to 2 to 1 to 5. There we go. We're done. All right. So next time we have a lab. The lab of build an adjacency list to matrix converter. So we'll jump onto that one next time. Thanks for watching the video. Don't forget to comment, like, and subscribe, and see you then.